Okay, our main goal with this video is to talk about the mean value theorem, but I want to actually open up with a theorem you should have already learned about called the intermediate value theorem, and the biggest reason for that is just so that we can compare and contrast them and realize that they are different and they are often confused for one another, so I want you to be able to use the right one in the right spot. So just as a quick review, the intermediate value theorem, intermediate kind of stands for in between or in the middle, and all it says is you can't go from here to here without at some point crossing here. And we are going to exclude weird instances like holes or jumps or breaks or discontinuities or asymptotes. That sort of stuff could let you get around these theorems, but if you have a nice smooth curve that goes from point A to point B, at some point you've got to be at this height right here. That's the intermediate value theorem. And they sound the same. They both say something value theorem, so I don't want you to confuse that with today's topic, which is mean value theorem. So let's move on to that. Okay, so here's mean value theorem. And the reason it's called mean, which you know is average, is because of the average rate of change. The average rate of change is just the slope between 2 points. So what the mean value theorem says is choose a function with 2 points. And again, we're excluding functions that are not continuous and differentiable. So we aren't going to allow sharp points or vertical asymptotes or jumps or holes or anything weird like that. But the mean value theorem says pick any 2 points on a graph and figure out the slope between them. So here's an example, and these 2 points have a slope of 1 between them. We go up 6 and right 6, so that's a 1-to-1 ratio. So this line has a slope of 1. The mean value theorem says whatever the slope between 2 points. I'm going to try to get this down in as understandable a way as possible. Whatever the slope between 2 points the tangent line, or let me put it this way, the derivative will have that slope at least 1 point in between. Okay, so a technical math person would probably read this definition and shudder, but this is what it means. Whatever this slope is, I can't get from point A to point B without at some point having a tangent line with the same slope. In this case, it's actually going to happen twice. My derivative will have a value of 1 at 2 places in between -2, 6 and 4, 0. One of them is about right there where my tangent line has a slope. It's parallel to the line that I already drew. And another one is about right in here. I'm just estimating in this case. So what I'm guaranteed is if I have a smooth curve, pick any 2 points, and whatever the slope is between those points, my derivative has to have that same value. And what is a derivative? A derivative is a function that will give us the slope. So the slope of this is the same as the slope of this, which is the same as the slope of this. That's the mean value theorem. Okay, so let's look at an example. What value what value C, and usually this is called A and this is called B, and we call the value in the middle C. So look, recognize C when you see that letter. It's sometimes a clue that you're talking about mean value theorem. What's the value C that is guaranteed by the mean value theorem? So whatever the slope is from point A to point B on this graph, let's figure out where the derivative has that same slope. So that's going to start, I like to just find the slope first, so I know what I'm looking for. F of 2 minus f of -1 over 2 minus -1. This is what's going to give me the slope. And I will save you the details. F of 2 minus f of 1 is 14 minus 2. You can plug and chug that if you wish. And 2 minus -1 is 3. So this is 12 over 3, or 4. The slope between the points, and I don't need to be looking at the graph, I can just envision. I'm going from -1, 2 to 214, and that gives me a rise and run of 12/3. So the slope between these 2 points is 4. This theorem guarantees that at some point between -1 and 2, I'm going to have a derivative that equals 4. All right, because this is, and I should say this is continuous and differentiable. This is a nice, neat polynomial function. There are no sharp points, asymptotes, nothing weird going on. So next I'm going to find my derivative and set it equal to that value of 4. All right, and sometimes that's pretty, sometimes it's not. Let's see what happens in this case. The derivative of f is 3x squared plus 4x minus 1. And because I know that the slope from point A to point B is 4, I know that my derivative at some point has to have a value of 4. So this is the equation I need to solve. As with any quadratic equation, I want to get 0 on one side. I'm going to subtract 4 from both sides and make it -5 is equal to 0. It would be nice if this factored. That would give me nice, neat answers. This one is not going to factor. But again, I'll save you the details. I would put 3, 4, and -5 into the quadratic formula, and x equals -4 plus or minus the square root of 76 all over 6. Okay, I'm trusting you can do that at this point. And if I put those into my calculator to get decimal values, I get 0.786 and -2.1196. Now one of those I'm interested in and one of them I'm not. All right, remember where I'm looking. I'm looking on -1 to 2. So this is the value guaranteed by the mean value theorem. Somewhere between -1 and 2, I have to get a slope of 4, and that's going to happen right here. I also have a slope of 4 at another place because this graph does some turning around the coordinate system, but it kind of confirms what I was looking for by getting an answer between -1 and 2. So this is just one way you could apply the mean value theorem, and that's to find the value in between A and B that has the proper value of the derivative. So that's what we did here. Okay, so this next theorem is called Rolle's, and Rolle's is actually one specific case of the mean value theorem where the slope just happens to be 0. So Rolle's theorem basically says you can't go from point A to point B, and those are level with each other, without at least one point in between having a horizontal tangent line. Technically, you could go your whole calculus life and never know Rolle's theorem, but it does have a name, and it might pop up. So I just want you to realize Rolle's theorem is just one specific case of mean value theorem. It's kind of like the Pythagorean theorem, a squared plus b squared equals c squared, is just one specific case of the law of cosines. All right, check that out. Think about that, or we could talk about it later. But this is just one specific case. So Rolle's theorem is the mean value theorem where the slope just happens to be 0. So let's apply that to this function and figure out where in between 0 and 2 pi does this thing have a slope equal to 0. We need to know, if Rolle's theorem is going to apply, we need to know that these two values, f of 0 and f of 2 pi, are on the same level. So let's just start by confirming that. F of 0 is 2 cosine squared of 0 plus 2. Cosine of 0 is 1, right? Remember your unit circle, 0, x value, yes, cosine's 1, times 2 plus 2 equals 4. And f of 2 pi is 2 cosine squared of 2 pi divided by 2, which is pi plus 2. So cosine of pi is -1, square it, you get +1, times 2 plus 2 equals 4. So Rolle's theorem applies because these things are both 4. They don't have to be 0, they just have to be the same, because the slope between 0, 4 and 2 pi 4 is a flat line. That's a slope of 0. So don't, if you're checking to see if Rolle's theorem applies, the values don't have to be 0. The slope between the 2 points has to be 0. So now my question is, at what point is the derivative of f equal to 0? All right, so what's the derivative of 2 cosine squared x over 2 plus 2. Well, this is a power rule first. This is something squared. So the squared is going to drop down and multiply by the 2 that's already there. Then it's going to decrease to the first power. I'm going to leave x over 2 the same the first time through, but then the chain rule is going to require me to multiply by a half. And then the derivative of this plus 2 is 0, so that's not going to show up at all. Okay, so if I simplify this a little bit, I just get 2 cosine x over 2. All right, the 1/2 and the 4 I combine to make a 2. So Rolle's theorem, or the mean value theorem, either way you want to think of it, guarantees me that at some point this has to equal 0. I have to have a horizontal tangent line at some point. So this does involve trig, but it's not that complicated. This is going to equal 0 when cosine equals 0, because technically I divide both sides of the equation by 2 and just get rid of the 2. So I need to know where is cosine x over 2 equals 0. Well, when I evaluate cosine, it's 0 whenever I'm on the y-axis. So that's at pi over 2. And technically that's at pi over 2 plus pi n. But the value I'm going to get is actually going to come from just the pi over 2, because I'm only looking on the interval 0 to 2 pi. So I'm going to ignore that for now, and we'll see why when we look at the picture. But if x over 2 equals pi over 2, then that implies x equals pi. So the x value, the c that we used in the last problem, that's going to be pi in this case. To get the full point, let's figure out what f of pi is. F of pi is 2 cosine squared pi over 2 plus 2. And cosine of pi over 2, that's the top of the unit circle where the cosine is 0. 0 squared is 0, times 2 is 0, plus 2 is 2. So the point in question should be pi 2. This is the location that has a horizontal tangent line that I'm guaranteed by Rolle's theorem because the two endpoints gave me the same height, which means the slope was 0 between them. So we'll finish up by looking at a picture. Okay, so 0, 4 was my one point, 2 pi, comma 4 was my other point, and pi over 2 was the answer. If these two points are horizontal, then this slope equals 0. So therefore, somewhere my tangent line had a slope of 0, and that's the point we found using Rolle's theorem. But don't forget, Rolle's is no different from mean value. It's just the specific case where the points happen to be on the same level, creating a slope of 0. So that's the mean value theorem. Learn it, love it, know it.